So the last thing with continuity is this theorem, intermediate value theorem. We only tackle a few theorems. This is the first one we tackle. IVT, sometimes it's called intermediate value theorem. Okay, so the intermediate value theorem. So here's what it actually means, and then I'll explain what it is, because it sounds a lot more complicated than it really is. The idea is really simple. The intermediate value theorem states that if a continuous function, okay, so the function has to be continuous. That's the first thing. Okay, that's important. It has to be continuous with an interval from A to B, means it starts at A, ends at B, as its domain, so x values. And it takes values f of A and f of B, means those are the y values. So A would be x, f of A would be y, B is x, f of B is y. At each of the interval, then it also takes any value between f of A and f of B at some point within the interval. So really what that says is, so picture I'm here, the door is there. Now picture a big blue line from the back wall, straight line up into this wall. So from there to there, there's a big blue line there, right? There's a big blue line. I'm here, door's there. If I'm here, you guys go outside, and when you come back in, I'm over here. What conclusion could you have made?
That's point A, that's point B.
What else? That's my starting, that's my ending. But what else could you determine by?
You passed blue line.
I had to have crossed the blue line somewhere, right? That's the intermediate value theorem. All the intermediate value theorem says if you start here and end there, you had to have crossed over every y value in between, as long as it's continuous, okay? Because if it's a jump or an asymptote or something like that, a hole, then intermediate value theorem doesn't apply, okay? So yeah, exactly that. If I start here and I end here, I had to have crossed the blue line somewhere. Where? I don't know. When? I don't know, but I did cross it, okay? That's what the intermediate value theorem says. So here's kind of an example of that. If I start at A, finish at B, I had to have crossed that line somewhere, okay? So we're gonna do two things. First thing we're gonna do is we're gonna, I don't wanna say prove because it's not a prove, we're not gonna prove it, but we're going to verify. We're gonna verify that the intermediate value theorem applies. That's the first thing we're gonna do. The second thing we're gonna do is we're gonna figure out where did it cross? Where is that little blue dot? Where did it cross? That's the two things we're gonna do.
So is it like the x value always linear as in like there would never be like 2 points? Like you know how it's like a squiggly line, right? Is there only like go back before it hits the point?
So yeah, so then it would be a function. So if it went back like that and came back like this, it wouldn't be a function. So that's part of the requirement for me to use this. It has to be continuous and it has to be a function. Yeah. So like, yeah, could I start at A, then go backwards and then come up here? Then it becomes non-function, not a function, right? I could just jump, right? Go from here straight to there, jump. But then that would be a big discontinuity, right? It would be jump discontinuity, right? So that's why those don't apply. It has to be continuous and it has to be a function, okay? So there's a couple things. First thing, when they talk about a zero, when they talk about a graph's zero, a zero on a graph, what do they mean specifically?
Start.
Not the start.
Where it crosses the zero axis?
Where it crosses the x-axis, exactly. A zero is where it crosses the x-axis. So if these are the two axes, here's the y, and here's the x. The blue dot, oops, not blue anymore, let me make it a different color. The red dot is a zero, right? We call it a zero. It's got many names, solution, can't think of the other, roots, right? It's got many, many names, x-intercepts, but all of those are the same thing, a zero. So when they talk about a zero, they're asking where did it cross the x-axis? Okay, that's what they mean. All right, so that's the idea. That's the whole idea. Okay, if I start here and end there, and I'm continuous and I'm a function, I had to have crossed every y value in between. Okay, couldn't have skipped. So let's look at, so we're going to explain why, we're going to verify. 1 and 2 are kind of verification. Verify why the function has a zero.
Do we draw those graphs?
Here's the thing. When I'm using the intermediate value theorem, it's not a theorem you use a lot, but when I use it, I always like to draw a graph because it helps me visually. Helps me visually. Some people don't need a graph. Great. I personally need a graph when I draw it. So do you have to draw the graph? No. But for me, like I said, it's always helpful. Okay? So here's the function. Do I have to worry about discontinuity with this function?
No.
No, why not?
A 1 under.
Exactly. There's no bottom. There's no denominator to make it undefined anywhere. So we know it's always going to be, it's going to be a cubic. It's going to be a cubic. Okay? That's the first thing. Okay? So it passes that. It's a function. I can plug in a value anywhere, any number for x, and I'll always get a y. And it's continuous for the same reason. Okay, so they want to know, is there going to be a zero between 0 and 1? In this little interval here, will there be, are you guaranteed a 0? Well, I got to figure out where am I at the start of the interval and where am I at the end. That's what I'm going to figure out. Okay, that's the first thing I'm going to do. So to figure that out, I'm going to plug in 0 and I'm going to plug in 1 to see which y value I'm at. So I'm going to plug in 0 first. 0 cubed plus 3 times 0 minus 2. I get negative 2. So at 0, when x is 0, y is negative 2. So now I'm going to plug in 1. Where am I at? At 1. 1 cubed plus 3 times 1 minus 2. 1 plus 3 minus 2. 4 minus 2 is 2, positive 2. So at positive 1, I'm at positive 2. Okay. Start, I'm at 0, negative 2. Finish, I'm at 1, positive 2. We said it's a function. We said it's continuous. So that means I have to cross that green line somewhere. Somewhere I have to cross the green line. Where do I cross it? We'll do that later. But for right now, I had to have crossed the green line.
So past that, like, that triangle quicker?
So it has to pass there. For me to start here and end here, I'll call one A and call the other B. This is A and this is B. If I start at A and go to B, I had to have crossed the green line somewhere because it's continuous and it's a function. Okay? It says in words, but I'm not really big, you know. If this was a test question, I'd answer it in words, but you know, you get the idea. You get the idea. Okay? Same thing, number two. Number 2 from 0 to pi. So now it's a,
Wait, so how would we enter the first? Do we just put a equals negative 2 and b equals, or do we just
yeah, so you just explain the y values. From it, you would explain it's a function, it's a continuous function. F of x is a continuous function. The interval is at 0, negative 2, and at 1, 2. Therefore, IVT applies. Intermediate value theorem applies. So that means you would have to have a 0. That's what you explain in your own words, kind of that thing. They don't ask you to explain in your words a lot, so that's why I'm not really harping on that. It's more how to use it. Okay? So now we have a a trig graph. It's got cosine on it. It goes from 0 to pi. So 0 to 3.14. Okay? That's where the interval is. So they want us to know, is there a 0 between there? Well, where do we start? Where do we end?
0 and pi.
So we're going to plug in 0, right? And we're going to plug in pi. Figure out where we start, where we end. So 0 squared minus 0 minus cosine of 0. Zero squared is 0, minus 0. Cosine of 0 is positive 1. Negative 1. Okay. Now I'm going to plug in pi. Let's see, f of pi.
Wait, so why did you negative 1?
What's that? 0, negative 1. That's the first. That's where the interval starts. Pi. Pi is a number, so you plug it in just like a regular number. Pi squared, so it's 3.1415 squared, minus pi, minus cosine of pi. Okay. Pi squared, I don't have a calculator, so I'm just going to say pi squared. I'm going to leave it as pi squared. It's 3.1415, that long number, squared, times itself. So it's going to be like 12. It's like 12 point something. Minus a pi, minus cosine of pi.
Which is...
If you go to your chart, so if you go to your, let's see, do I have my chart up here? Oops, that's the wrong one. I don't have my chart here. It's actually 1. It's actually 0. It's actually going to be 0. It's on your chart, cosine of pi. So 0 minus 0.
So pi squared minus pi.
So pi squared minus pi. So roughly 12-ish minus 3-ish.
So 9-ish.
So around 9. Around 9. Positive number. Definitely a positive number. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So somewhere over here.
Can we just do 9 and margin error like 1?
There you go. Yeah, all that's important is that it's above the green line. That's the main thing. It's positive. The y value is positive. Because now I can show you, this is another reason I do it. Instead of writing it out, I'd like just show. The blue dot starts there, blue dot ends there. Here's another question. We didn't ask, is this continuous? Is there anywhere cosine? We know x squared minus x, not a problem. But is there anywhere cosine will be undefined, or cosine won't have a value? Let's see. Let me bring up my table. Cosine. Is there anywhere cosine has an undefined? Nope, cosine has a number everywhere, right? 0, 0 is okay. So cosine is defined everywhere. Same thing with sine. Tangent has some undefines. Cotangent has some undefines. Secant, undefines. Cosecant, undefines. But cosine and sine don't have any undefines. They're defined everywhere.
Undefined on like a chart. I mean on like a graph. Does that look like anything?
It would be like an asymptote.
Oh.
So like, let's see.
As in it goes to like reach the thing.
Yeah, so like, here you go. So at tangent, it's got an asymptote at negative pi, positive, or pi, negative pi over 2, positive pi over 2. So it's got like those asymptotes there. Sine and cosine don't have any asymptotes because they just go on forever. Okay? Okay. So, yeah, it applies. IVT applies. We'll just say that. IVT applies. IVT. If they're asking for zeros. If they're asking for zeros, yes. then it wouldn't apply. Or if one of these guys, if either f of x, if we noticed, hey, one of these guys isn't going to be continuous somewhere, has a continuity problem, then it wouldn't apply. We have to make sure it's continuous. No, just like if any of these guys would have discontinuities, a hole, an asymptote, a jump, those kind of things, yeah. Okay, all right, so let's go. Let's go. This is more of the question you're going to have. This is more of the question. Two things we have to do. Verify that it applies. The intermediate value theorem applies, so verify that like we did before. And then tell me where it crosses that magic line. Where does it cross that magic line? So now we're asking not only does it, we're asking where. Okay? So they throw in some extra stuff here. So here's our function. Here's our interval. And then they throw in this stuff here. This is the y value. That's the y value. So where is the y? Where is your y value? Think of a graph. Where is y always equal to 0? Where does it always equal 0? So on any graph, where does y always equal 0? What do we call it? This has got another name for it. Where on this is y always going to be 0? There's a special name for it.
The y-axis?
Yeah, or the x-axis. It's called the x-axis, right? This is 0 here. Everywhere here, it's 0. So we call that the x-axis.
So the x-axis would be the y-axis.
No, not the y-axis. It would be the x-axis. So in other words, where is y 0? Everywhere on the x-axis. So they're asking where. So let's draw my graph real quick. Let's draw my graph. From 0 to 3. 0, 1, 2, 3. So two questions. Is it going to cross that yellow line, and where? Because the y value is 0. Where is the y value 0? X-axis. And I only want to go from 0 to 3. I don't want to go anything higher than 0 or 3, or than 0 to 3. So the first thing is, does it apply? Well, it's a continuous function. We know that. So let's figure out where it's at 0 and where it's at 3.
Can we do 2, 2, or can we do 2 as well, or no?
No. Just where it starts, where it ends. 0 squared minus 6 times 0 plus 8. 3 squared minus 6 times 3 plus 8. So the first one is going to be positive 8, 0, 8. The second one, let's see, we get 9 minus 18 plus 8. 9 minus 18 is negative 9, plus 8 is negative 1. So it is going to cross. So we know that the intermediate value theorem applies. IVT is going to apply with this guy. That's where we ended the last problem. Now they want us to go a step further. Where does it cross? Where does it cross? So to figure out where, you're always going to do this. You're always going to set the function equal to the y value. You're always going to set the function equal to the y value and solve.
So set it equal to 0.
So this time we're going to set it equal to 0. The next one we do, we're going to do one more together just to kind of give you some practice. It won't be 0, but this one will be 0. So we're going to set this guy equal to 0. So x squared minus 6x plus 8 equals 0. We're going to get two answers because it's a quadratic. So you're always going to set the y value equal to your function. Okay? So it's a quadratic. To save some time, you're going to figure out what number multiplies to be 8 and adds up to be negative 6. What are the two numbers that multiply to be 8, add up to be negative 6, right?
Yeah.
Negative 4, negative 2, right? And then eventually you'll get x minus 4 and x minus 2. Right? That's how I got negative 4 and negative 2. And then when you set those equal to 0, you're going to get two answers. You're going to get 4 and you're going to get 2.
But isn't 2 the only one that we can actually test out?
Exactly. 2 is going to be the only one that we will accept. Why will we not accept 4?
Because past 3.
Because it's outside the interval. There you go. I only care about 0 to 3. I could care less what happens after 3 or before 0. Could care less. So the only one that applies, so what is the value of C? 2. C equals 2. So that means when x equals 2, it's going to cross. So we know at this red dot, it's going to cross. It's also going to cross at 4, but I don't care about 4 because it's not in my interval.
So from it, it's pulling.
It's a quadratic, so it's going to come down and let's go back up. Doesn't really look, it's going to be a quadratic. It doesn't really look because my graph's not to scale. But yeah, that's what it's going to do. It's going to come down, then go back up. That's what quadratics do. They go down, they come back up, or reverse. They go up, then they go down. Okay?
It's constant with every quadratic.
Every quadratic, yeah. Okay, so one more, we're done. So here's f of x. Here's the interval, rough 2.5 to 4.
This one's a whole or unfinished.
So it's going to have some, this one's going to have some issues with discontinuity. So you're going to have to verify that we can use the intermediate value theorem. And on this one, actually, I'll give you a little preview. It does have a discontinuity. It'll have, this one's going to have a vertical asymptote. But at 1. But we don't care about that. Why not?
Because it's still a function.
'Cause it's
No,
set to
you're
0.
close.
Set to 0.
Say what?
Is it because we know our values right now?
Which values are you talking about?
The interval?
Yeah, the interval goes from 2.5 to 4. So do I really care what happens when x equals 1? No. So is there discontinuity? Absolutely. But we only are focused on this, we only want a snapshot of it. And in that snapshot, I don't think there's going to be any discontinuity. So again, there will be an asymptote at 1, but I could care less because it's not in my interval. 1, 2, 3, 4. The only place I care about is from 2.5 to 4. That's the only place I care about. 2.5 to 4. Within that interval, you're not going to have any discontinuity. Okay? Because the only one we'd have is at 1. So first thing, verify. Verify that it applies. We know it's going to be continuous, but does it? Oops! I totally did it wrong. Or not totally. I missed something. I put the blue line in the wrong spot. Where is that blue line? Where should that blue highlight be? Not at 0, at 6. At 6. So this is still going to be 2.5, and this is still going to be 4. But 1, 2, 3, 4, 5. That's the line to cross.
Cross that one. Mm-hmm. I thought it was across 2.5 or 4.
No, that's the start of the interval and the end of the interval. So again, if you can, this is really what I'm doing. I'm zooming in because I only care about 2.5 to 4. So we got to figure out what's the y value at 2.5, what's the y value at 4. So when you plug it in, it doesn't matter if you do 2.5 or 4 or 5 over 2. It doesn't really matter, whichever one's easier for you. These are non-calculator questions, so 2.5 might be easier. 5 over 2 might be easier. So we get 5 over 2 squared plus 5 over 2 divided by 5 over 2 minus 1. Five over 2 squared. Square the top, 25. Square the bottom, 4. That's how you square fractions. Square the top, square the bottom. Plus 5 over 2 over 5 over 2 is 2.5. Minus 1 whole is 3, is 1/2. 1.5. So that's 3 over 2. Okay. So combine common denominators. Common denominators on top is going to be 4. So you're going to get 25 plus 10 is 35 over 4. $35 over 4 is like 8 point something.
8.75.
There you go, 8.75. And then 3 over 2 is 1.5. So if you're dividing fractions, remember, keep the first one, change the fraction to multiplication, flip the second one. And then you can do some cross canceling. You can divide both of these guys by 2. So you'd get 35 over 6, which is approximately 5 point something, 5.8, 5.9, almost 6. We'll say 5.9. So just under that. So when x is 5.2, y is 5.9, so just under that blue line. Okay. Now we're going to plug in 4. F of 4. 4 squared plus 4, 4 minus 1. 4 squared is 16, plus 4 is 20, over 3. That's like 6.6, 6.7.
Wouldn't that be like 6.4? Closest interval of 6 is 24.
What am I thinking?
That's
Yeah, it's going to be over 6, yeah. Definitely over 6, right?
Maybe over 6.
That's the main thing, yeah. Because if it's over 6, that means it's on the other side of the blue line. So it crosses. It's going to cross. Last step is, where does it cross? So IVT applies. Where does it cross? Well, to do that, remember, set f of x equal to the y value. So f of x is x squared plus x over x minus 1. What is our y value? 6. How do we do this? There's different ways to do it. Easiest way is probably cross multiply. Make that a fraction. Do cross diagonal multiplication. Anytime you have a fraction equal to a fraction, you can do that. So you're going to get x squared plus x equals 6 times x minus 1. Distribute the 6. 6x minus 6. Set it equal to 0 because it's a quadratic. X squared minus 5x equals negative 6. X squared minus 5x plus 6 equals 0. So one more time. What are the two numbers that multiply? Negative 6, positive 1. The two numbers that multiply, actually no, that won't work. Because it doesn't multiply, it's got to be multiplied to be positive 6. That, there you go. Negative 2, negative 3, yeah. Minus 2, minus 3. So you're going to get two answers because it's a quadratic.
The only one we can do is 3.
There you go. But the only one we can use is positive 3 because it's within the interval. So C equals 3. So that's where it's going to cross, at 3. Okay? So when x equals 3, that's what's going to cross. All right. That's the intermediate value theorem. That's how to see if it applies. I don't want to use the word prove because it's not a proof, but it's how to show how, does it apply? Yes or no, verify. And then where is it going to cross? Where is it going to cross? Okay? And that's the last thing for this unit. So today, the rest of today, what do we got? About 13 minutes or so. Mainly take a look at the practice. Try a few. If one is not making sense, ask, please. And then tomorrow, Thursday, you'll have a chance to work on the practice, but I'll also give you the test review, the chapter review. Okay?